Now that we've got our linear model, we're going to do a few other non-linear regression models. So going back to Plotly, here's my linear model that I had. And right up here, I'm going to go ahead and press this X to completely get rid of the linear model. And go back and press Analysis, go down to Curve Fitting, press on Fit, Chart Type, go ahead and select B again. And instead of linear, let's do quadratic, and go ahead and press Run. And then here's all my information about the quadratic model. And we can see that this quadratic model, this parabola, fits our data quite a bit better than the linear model. The R-squared value, it claims is 1. It's not really 1. If you wanted to see what it really was, you could press on Add Results to Annotation. And then here you can see that it just rounded it up to 1. Now it's going to be kind of crazy on me here, but it's 0.9971. So what I want you to do is to take a screenshot of this. And again, how do you take a screenshot? You press Control and the Switching Windows button on your Chromebook, or if you're just using your laptop, press your Print Screen button and paste that picture into the same Google Doc or Word document that you put your linear regression screenshot in. Okay, and let's go back to Plotly now. I'm going to go ahead and deselect the Add Results as an annotation because I don't really need all that. And if I leave it there, it kind of messes with stuff later on. So I'm going to go back to my Word document where I was starting to keep all of my information in. So not my screenshots, but you could have your screenshot with your linear regression model stuff that we did in the previous video. But I'm going to jump down a couple spaces here, and I'm going to type in quadratic regression, if I can spell here, regression model. And it is y equals, and now I've got a, b, and c, which represent the x squared, the x, and the constant coefficients. And I'm going to use, again, the unformatted fit parameters here. Now, the a value is the x squared coefficient, b is the x coefficient, and the c is the constant. Okay, so I'm going to go ahead and copy first my a value here. So copy it, go back to my Word document, paste it. Then this is times x to the second power. Or if you want to do a superscript squared to make it look legitimate, you certainly could do that. But Wolfram Alpha can read both things. Then we're going to go back and grab our b value. Now notice the b value is negative. So when you copy this, if you want to copy the negative with it, we can just say plus and then paste in the negative to go with it. Or you could just say minus the 162 number. So that's times x. And then finally the constant, the c value, it's positive. So I'm going to say plus and then that number. And there's my quadratic model. I'm going to go ahead and write down again what the r squared value was. I mean, it really told me it was 1.0, so I'm just going to write 1.0. Again, the mean squared error was 2.6. All right, and so now I'm going to do the same two things I did in the linear model. I'm going to predict infant mortality for the year 2050, and what is the predicted year that infant mortality reaches 0, but with my quadratic regression model instead of my linear. Okay, so I'm going to pop down here, and we're going to say predicted infant mortality rate for the year 2050. And I'm going to grab my regression model, copy it, paste it down here. And then where the x is, I'm going to pop in a 2050. And I remember there are two places where there are x's. Do 2050. And then I'm going to copy all of that and go back to Wolfram Alpha. And then I'm just going to paste this right up here. So this will tell me what y is equal, all of this math. Let it do its thing. And it tells me right here. So I'm going to copy that and come in and paste it. And I'm going to take out that extra space in there. So notice with our linear model in the year 2050, we predicted a infant mortality rate that was negative. But with our quadratic model, it actually makes it not negative. It's not really anywhere near negative. It's still 68.302374. The main reason that is because our quadratic model fit better than our linear model. So this should be a little bit better prediction for what really the infant mortality rate should be in the year 2050. All right, the other thing we're going to do is do the predicted year that infant mortality reaches 0. And so I'm going to come back up here. Well, let's see now. We'll just take this one. Take all the equation. And this is where we wanted to put 0 in for y, because y was our infant mortality. So I'm going to copy that, go back to Wolfram Alpha, clear that out, paste that in. And so now this is going to solve for x. And since I have a quadratic model here, I should technically get 2 answers. And so let's see what kind of values they give us. And this is going to be kind of a solution that we'll get where we'll need to discuss this. If I look down here, there's really a complex solution. And so since I have a quadratic model, I should get 2 answers, but I should get either 2 real solutions, 2 complex solutions, or it could happen that I have 1 real solution that is a repeated root. That would be where the graph just touches the x-axis exactly at that point. And so this really isn't going to give me much information here. You might think, well, in the year 2031 is when we would expect that to happen. But this is, an imaginary root here. Our quadratic model, notice the a coefficient is positive. So that means my parabola is going to be more U-shaped, which means eventually it's going to curl back up. And if I went back to Plotly real quick here, you can see that this is the kind of the left arm of that U shape for our parabola. And somewhere in the future, that U shape is going to have to go back up, right? So by the time it gets to, before it gets to the year, or no, I guess maybe it's going to be around the year 2031. I'm going to bet when it gets to around 2031 on our x-axis, it's not going to hit there, but it's going to reach the minimum value of the parabola. And then it's going to start going back up in the other direction. So I guess you could say the lowest, the minimum, I would say would be at 2031. But it's never really going to hit 0 due to our quadratic model being like this. Okay? So here's what I'm going to say. I know I just said a bunch there, and you're probably wondering what on earth is going on. I'm going to say there are no real solutions present, but, and then I'm going to use the real part of this, because this does tell me the minimum here. So, but in the year 2031, the quadratic model reaches a minimum. And we don't quite know what that minimum value is, but based on the quadratic model, that's when the minimum truly would be at in the year 2031. And we're kind of done there, okay? You might end up with a quadratic model where maybe you really do get some real solutions, that there are no complex solutions. And that's fine. Just pick whatever one. If you get 2 real solutions, one of them is probably going to be something in the future, which is the one that we want, and you'll probably have something else that goes back in time, and that's the one we don't want, because you might end up with kind of jump ahead here. You could have a quadratic model that has a negative a coefficient, which means it's an upside down u. And so maybe this is like your data that you've got right now between 1960 and 2015. And so when we're solving for 0, you might end up getting something that happened back in the past, which is the value we don't want. But the bigger number that is, sometime in the future, that would be the solution that you're looking for. So this is the good one that you want, and that's a really bad star. Let me try something bigger there. So if your a value is negative with a quadratic, give me the future value. Don't give me the past value. All right, and that's really it for the quadratic regression model. So we've got our linear stuff up here, we have our quadratic down here. We still have to get to 2 more regression models. And in the next video, I'm just going to show you really quickly where you're going to get those things and some things that are going to pop up to be a little bit different.